Hey everyone, my name is Robert Cole. Welcome to my presentation on Secure Shell and Transport Layer Security. With that said, let's jump straight into it. First thing I wanted to go into is what is SSH? SSH is essentially just a protocol that prevents clear text transmission of data across networks because having clear text transmission, it's easy to sniff out any traffic and see what's happening on it. So that would include passwords and whatnot. So back in around 1995, I believe, SSH was thought up and created. It essentially replaced Telnet, and it works. It operates on port 22, and the basics of how it works is I ripped this straight from the website. Upon receiving a connection request, the server sends the client a set of supported encrypted protocols, and then the server uses its public key as an authentication method. And then the client compares the protocols to its own set. If there are any matching protocols, the machine agrees to establish the connection, and then the user is able to authenticate. It's got quite a few steps in it, but it ensures that it ensures that you are having a secure line essentially between one point to another. All right, and then here's a few of the things that I pulled this from one of the SSL to buy wiki, and it covers what each version of SSL has. So the SSL 1, due to a security flaw, it wasn't released. You had version 2, which had its first public release by the SSL Netscape, and it was released in '95, as I said earlier. There were design flaws that compelled Netscape to release a version 3, although 2 was only deprecated in 2011. And then the third version was one that is a version that fixed the SSL2 vulnerabilities, although it was deemed insecure due to the Poodle attack. If you want, you can look more into it on the SSL-to-buy.com. So after SSL version 3, they deemed it wasn't secure anymore. So around 1999, transport layer security is invented. And TLS is the successor to SSH, and it works pretty much the same way as SSH. It uses an encryption protocol to protect the transfer of information, and the two terms are pretty much used interchangeably. That's why you see SSL/TLS on most things. Some other things that our transport layer security has the advantage of is it has a faster handshake, and it requires the server to cryptographically sign the handshake, which SSL did not do. It was doing that. It was transmitting that to clear. And it no longer supports old vulnerability suites, which has an advantage because people can't mistakenly set it up with one of them. So then here's a few other things that with the transport layer security, we can just run through those real quick. Transport layer security in January 1999, it was allowed to, it was upgraded to that, but you're allowed to downgrade back to Secure Socket Layer version 3 after 1.1 was released in April 2006. It's a solid 7-year gap there. It was updated to TLS version 1. Added protection against hyper blockchaining attacks, and then March 2020, Google, Apple, Mozilla, and Microsoft and Amazon announced that it's finally depreciated. That was only 2 years ago. We all probably started school by then. Transport layer security version 1.2 was released in 2008. It had a hash algorithm. It allowed specification of the hash algorithm used by the client and server, and it allowed users to authenticate encryption, which was more suitable for extra data modes. TLS 1.2 was able to verify length of databases on data based on cipher seats. And then we have TLS version 1.3, which was released in August of 2018. It had removal of stuff like MD5 and SHA-224 support, which have been deprecated. And it requires a digital signature when either confirmed and uses the perfect forward security case public key exchange. Handshake messages are now encrypted after the server hello. So less clear text transmission. And we have a short little graph here that just basically explains the security side, secure side layer and transport layer, and TLS. So after the TCP handshake is established, then you get into this where the client message to the server and says, "I'd like to set up an encrypted session." So here's a list of cyber suites, and then I'm willing to use. The server responds with which one it's going to use, and it says, "Here's my certificate with my public key." Using that, the client then verifies the server certificate and then extracts the public key. The client then uses the public key to encrypt a pre-master key and send it to the server. The server then decrypts the pre-master key, and now they have a shared secret. This is what they're going to use to essentially communicate here. The client then sends the encrypted message. Multiple arrived at specification. Here, the encrypted message tries to decrypt using the shared secret, and then from there onward, all messages are shared using the shared secret. The server tries to decrypt the message. If it's successful, it says, "Hey, this is successful," and then from now on, I'm going to be using these for all my messages, the shared secret. And then from there, the session is started, and when it ends, you get the end message, and then the session is terminated through TLS. Okay, so real quick though, also, I'm going to cover over the OpenBSD Foundation. The OpenBSD Foundation is a security-focused, free open-source Unix-like operating system based on the Berkeley software distribution. It creates a lot of security features for Linux. Essentially, the foundation here, it also creates its own flavor of Linux, and they continue to develop various security protocols and whatnot. For instance, the OpenBSD Foundation actually created the sudo command, which I'm pretty sure we're all familiar with. If you're not, then you probably don't use Linux that much, which is kind of hard. I can't imagine how you get away in this class with that. It also made OpenSSH, which I want to go a little more into because OpenSSH on Linux, it uses OpenSSL, and then it's installed usually by default. You can usually access it by typing the OpenSSH command or OpenSSH command. What is it? Typing SSH. You can do SSH into a session, and then to check the status if it's running on your system, you can do the SSHD sudo systemctl status SSHD. Pretty simple to type in and see if you have it running on your system. And then, so real quick, we also have OpenSSH hardening recommendations. First thing I'm going to do is, if you do this in our class with the way we scan the labs, you'll actually get some points off, so don't do this for this. But in general practice, what you actually want to do is have it so your machine is only going to be listening for connections from certain IP addresses. You can set that up through the firewall. You can have it set up like I did. It's you have one allow packet, so above there's going to be a drop-all rule underneath for SSH communication attempting to this, but above it you're going to have an allow rule on your IP tables, and that should make it so that only those, and the allow rule is going to only be for a certain IP address or machine. You can also limit the max authentication attempts to prevent brute forcing, and that's through the sudo nano, and then you just edit it in the etc SSH and SSHD config file, and then you uncomment the max try line. You also can, in the same file, set a idle timeout line by typing in the SSHD config file and then uncommenting the client alive interval, and then you can set the interval for how long you want. And just some resources there. There was also the other ones through the wiki and all that throughout the presentation. And real quick, I'm going to jump in and just show you an example of how you can putty into a server and use it using SSH. So here, I'll cut over to that right now. All right, guys, I got my machine spun up here. So first things first, we're going to go over here and check the Linux. This is like the second time I tried to do this because I already logged in and wasn't recording the first. First thing though you're going to do is you're going to type in the command sudo systemctl status SSHD. SSHD is the Debian here that we're checking if it's running, and it is running since today. When I booted a machine up, it's good. Now, if we want to access this machine, we come over to our, say, other server, and I have it set up with on IP tables. I think I load eventually. So these SSH, basically, this is an accept from only the computer that I'm about to try to connect from, and then after that, just drop one from anywhere. But we come over to this computer, let's use PuTTY on port 22, 2.168.5. I think this one's 21. Open. And this lets me connect straight on in. And I could do, just to prove it, you can see the directories here. And then let's see if we can see if the SSH server is running or something else like that. So let's see, maybe if I pull up my IP tables again. And then it'll show me the same thing as we had on that server. So as soon as it loads. All right, well, that's just a little presentation on how SSH worked, or a practical application of it. Say I wasn't wanting to log into all these different ones, I could just remote in. And that's about all I have for you guys today.